So let's take a look at some of the mathematics behind Mendel's model. So since there are two alleles for each character, so there are two factors involved with each character, what you're dealing with then is 2 to the nth power will determine the number of gametes. So let's take a closer look at that. Okay, so the number of gametes is going to be determined by 2 to the nth power. So if we have a monohybrid, okay, monohybrid being 1, 2 to the first power is just going to be 2 different gametes. But let's say we have a dihybrid. So now we have 2 to the second power. That's going to be 4 different gametes produced. And so we can determine the number of gametes for each particular trait depending on that mathematics. So let's take a look at a dihybrid now. So now we've got a dihybrid, and we can see here that we have 4 gametes. Okay, 2 to the second power, 2 by 2 being 4. We have 4 gametes being produced here because they're of the number of combinations that can happen from 2 different alleles. Okay. If we were to take a look at the trihybrid, now we have a total of 8 different alleles that can be produced. Okay, bring this back. So now we have 2 to the nth power, in this instance being 2 to the third. So now we've got 2 by 2 is 4, by 2 is 8. I can produce 8 different gametes. Okay, this is the difference between your trihybrid and your dihybrid. But let's come back and take a look at the mathematics behind the phenotypic ratios. So in Mendel's monohybrid, we saw his data show us regularly 3-to-1 ratios. So 3 to 1 to the power of number of traits hybridized will give you the phenotypic ratio for that particular cross. So let's take a look at the dihybrid. Okay. Now we can go through that Punnett square and figure out how many of these are dominant, how many of these are recessive, or we can take a look at it mathematically. So let's say we have a 3-to-1 ratio, and we're looking at a dihybrid. So let's square that thing. Okay, so that is 3-to-1, but we have to FOIL that out. Okay. So now we have 3 by 3 is 9. 3 by 1 is 3. 1 by 3 is 3, and certainly 1 by 1 would be 1. Here is the 9-3-3-1 ratio that one would expect from the dihybrid cross. Okay. And if you were to take that to the next level, let's take that to the trihybrid. Certainly you could FOIL that out as well and come up with the phenotypic ratio for that trihybrid cross. So once again, Mother Nature writes a beautiful poem in the language of mathematics.